Hello guys, welcome you all for this end-to-end AIML and DL session where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot. We are learning a lot each and every day. Hope the same thing for guys. So as always, guys, if you guys are to this session, please make sure you guys watch all the previous session videos so that you can have a better understanding of what we are talking. Okay. And one more thing, please make sure that you guys attend the 2000 plus quizzes that we are having in the YouTube channel. Just go and attend it not a problem like you doesn't know or anything. Just go and have an attend. Okay. So yeah, guys, without wasting any time, let us jump into today's session. Today's session is a continuous of previous session where we have introduced you to the concept called as AN, that is artificial neural network. Let us start. Okay. So backpropagation, the heart of ANN training. Okay. Let's see what it is. Forward pass, data is feed forward through the network and prediction is generated. Simple. We have a data, we have input layer, hidden layer and output layer. We will pass the data onto it. Here, input layer takes the input, hidden layer process the input, and it will throw to the output layer which generate the probability value. That is called as forward pass. Error calculation, the difference between the predicted output and the actual output is calculated representing the network error. Okay. Finally, we will be getting the output, right, in a probability value. We will check this probability value with the value which is present in the actual data set and we will calculate the error. Then weight adjustment, the error signal is propagated back through the network, updating the weights of each connection to minimize the error. Okay, we got some amount of error. What we need to move pass back, that is from output layer to hidden layer to input layer. Like that, we need to make the backward pass such that we will update the weight so that we will get the output, that is a probability value, very closer to the value which is present in the data set so that we can minimize the error. Okay, iteration, the process is repeated for many training examples, gradually improving the network performance. So consider our output that we need is 10. Okay, first phase, first training, we get 1, we back propagate, we get 2, next we back propagate, we get 3, 4, 5, like that. We need to go for 10 iteration in order to get the value of 10, which is exact match of the output which is present in the data set. So this is what everything about the back propagation, which is the art of ANN training, how it works. Okay, guys, you need to have a clear understanding, guys, because like these are the black boxes. Never ever you guys gonna understand this. Without understanding this, you guys never gonna know how the algorithm works in the backend. Okay, so I'm pretty sure like anyone in this world can use data science algorithm, but the only thing difference is when we study data science, right, we can able to understand the black box behind it. So that's a major thing that we are here. Okay, so yeah, please try to understand, guys. If you guys have any doubts related to anything related to data science, just ping in the comment section, we'll take up and we'll solve your doubts. Okay, so yeah, so over to you.
The back propagation, the heart of ANN training, guys. These are very important concepts. You have to understand it. So forward pass, data is fed forward through the network. So you can understand by word. Okay, always focus. 90% meaning is in the words. If you understand the deeply the meaning of the words, you understand. Okay, and then you need to use the context and stuff, and then you will have 100% understanding what it is. So forward passes, data is fed forwardly through the network and prediction is generated. Simple, that's it. Error calculation, it is the difference between the predicted output and the actual. That's it, representing the the network's error. Simple. Error calculation is the predicted and actual, whatever you predicted and whatever is the actual. Weight adjustment, again an error signal in the propagated back through the network, updating the weights of the each connection to minimize the error. So we give to each data point, we always give weights. Okay, we convert into weight. That's what is weight. We give numbers. Like if you have seen in a priori algorithm, we have assigned weights and then it decides which product to keep where, right? So same way you have to assign weights and based on the priority it is going to, and then it is going to update the weights each connection and to minimize the error. Then iteration, the process is repeated for many training examples, gradually improving the network's performance. So this is how backpropagation works, and all these components are very important to understand it properly. Okay, and keep learning deeply the how the black box works. This is how the black box, when you understand what, why, and how, when you go and apply, application comes last. First you have to understand what and why. That is very important. Absorb the information, digest the information, and apply. Do all the quizzes and the assignments and the understand the concept. Do 360-degree learning with long-term objective function with patience, persistency, consistency, and perseverance. Keep learning deeply, guys. So that let's go to the other section.
Yeah, sure, sir. Let's move on, guys. Okay, what we are having next. Let's move on. Okay, convolution neural network. Okay, guys, this is what we're gonna see as a separate topic. Okay, but let's have a bit understanding of it. CNN, we have seen ANN, right? Now we see CNN. Convolution layer which extracts the feature by slicing the filters across the input, creating feature maps that captures the spatial patterns. Okay, guys, ANN is completely different. I'm gonna have a flavor of CNN, how it works. Means when we are having an image, right, we're gonna have something like a filters which gonna pass through entire image and creates a feature maps out of it. Pooling layer which reduce the dimensionality of feature maps, making the network more effective and reduce the overfitting. Because if they're going to be a larger image, it's going to apply the filter to the entire image. It creates a feature map for each and every filters. It will be very big, right? We use pooling layer to reduce it. Then fully connected layer, that is what we are learning now. ANN combines the extracted features to make the prediction, classify the image to the different categories. That is this part only we are learning now. This thing we are having a separate session where we're going to learn what is this convolution neural network, everything end to end. Why we have added this here means like there is a part called as fully connected networks, which is combines these two outputs to get the final prediction. Okay, so yeah, this is what all about this CNN, how it impacts on ANN, because these two things, okay, that we are having, right, this convolution layer which helps to extract the data or a meaningful insight from an image. This pooling layer is used to reduce the features or reduce the complexity of the data or a feature map that is obtained from the convolution layer. This fully connected layer makes to combine these two CNN and pooling layer in order to make the output, and finally it goes for the prediction by using this fully connected layer which performs the action of ANN. Okay, so yeah, yes sir, over to you.
Yeah, so we have convolutional neural networks. So it's called CNN, uh, concurring image recognition. So convolution layer is it extracts features by sliding filters across the input image. Okay, we usually use CNN in image recognition and other applications. So creating features, maps, and captures the spatial spatial patterns. Okay, and then we have pooling layer reduces the dimensionality of feature maps, making the the network more efficient and reducing overfitting. So you understand so we use different dimensionality reductions in machine learning, right? Same way we use pooling layer here to reduce this. Okay, fully connected layer combines the extracted features to make predictions, classify image into a different categories. So these are the elements of CNN which you need to understand deeply, and do reinforcement learning continuously, absorb the information, digest and apply the information. Keep learning with long-term objective function, a lifelong learner, that great mindset with patience, persistency, consistency, and perseverance. Keep learning deeply, guys. Let's move to the other section.
Yes sir, sure. Okay, then recurrent neural network, guys. These things we're gonna see. As I mentioned, like CNN, also we're gonna see a separate session. RNN, this is recurrent neural network. We're gonna see as a separate session. Now let us have an overview. Okay, RNN, like the recurrent neural network, mastering sequential data. RNN, LSTM, and GRU, these things we're going to see separately. Okay, RNN process the sequential data maintaining the hidden state that stores the information from a previous timestamp. LSTM address the vanishing gradient problem, enabling them to learn long-term dependency in the sequential data. GRU is a simplified version of LSTM, where offering a more effective and approach to handle the sequential data in a information. Okay, why I'm just going fast is like we're gonna see each and everything in a separate session, like a separate thing module like that. Okay, putting in a simple manner, this RNN, LSTM, and GRU is used to handle the sequential data, right? Like today there is a rain, tomorrow there going to be a rain. Okay, with what kind of amount of rain that we gonna get? For example, today is a 100 centimeter rains we get, means tomorrow 100 centimeter, and then day after tomorrow they're going to be 100 centimeter, because like it based on the past data 100, right? We're going to get the same thing. And it also carries out the historical data time. Okay, today, tomorrow, and the day after tomorrow, like it's gonna make sure the time is that. So this kind of layer, that is recurrent neural network, as or allow us to treat the data in a time frame. Okay, it includes the factor time also. Okay, instead of going for without time, because in ANN we doesn't have any kind of a time related thing. CNN also there is no time related thing. The only layer which has time with it is RNN, LSTM, and GR. Okay, so that is what this recurrent neural network does. It will go for a sequential data together with the adding a flavor of time with it. Okay, so yeah, sir, over to you.
Yeah, so RNN, you call it recurrent neural network. So mastering sequential data. Okay, so RNN, the process it processes the sequential data by maintaining hidden state that stores information from previous time steps. So LSTM, you already know LSTMs. I think they addresses vanishing gradient problem. We have learned in machine learning the LSTMs. Okay, so addresses the vanishing gradient problem, enables them to learn long-term dependency in the sequential data. So GRUs, this simplified version of LSTMs, offers a more efficient approach to handle sequential information. So if you see, it is all about sequential data. They are going to like maintain the hidden state, RNNs and LSTMs. They are going to address the vanishing gradient problem, enabling it to learn long-term dependencies in the sequential data. Again, GRUS is again, it is having efficient approach to handle sequential information. So it's all about like these are going to help us in the sequential data in different manner. Okay, different approaches. Okay, keep learning deeply, guys. Let's go to the other.
Yeah, sure, sir. Let's move on. Okay. Okay, so we have completed this recurrent neural network, right? Let's move on to this. Okay, so what we're going to see means what are the future advancement and applications of this ANN. Okay, only ANN, guys. We does not need to talk about the CNN or RNN, because like those going to be separate modules. Okay, let's see what are the futures and applications of this ANN. Enhanced learning, yeah, researchers are exploring a new architecture and training methods to improve the RNN's ability to learn more complex pattern from complex pattern. Okay, already we have a structure how it learns, right? As a researcher, they are developing some different kinds of algorithm to make this furthermore learn this complex task. Novel applications, yeah, ANNs are bringing or being applied to emerging fields such as robotics, autonomous vehicles, and personalized medicines, driving innovations, everything, guys. Okay, I hope like today in the world of 2024, we are having everywhere this deep learning network. Okay, because it making some revolution, right? Self-driving cars, like without any kind of humans, autonomous robots, and arms, everything, right? Today, so those are like novel application which makes useful for a mankind. Okay, that's a major thing. One thing from my side, like whenever you invent something, it should be very very useful for humans. Okay, because like end of the day, as a human, we are the consumers, right? You should safeguard us, and we should be useful for us. Okay. Finally, ethical considerations. As CNN becomes more powerful, ethical considerations such as biasing and transparency are crucial to ensure responsible use. Yeah, we mentioned, right? I think in the start of the session itself we have mentioned, right? We are as a data science learners and teaching profession or doers, we should be in a manner, we should have some ethics. Okay, major ethics is like we should use only legal data, we should safeguard the data. That's a major thing. Okay, so yeah, these are the applications and then challenges, like future advancements and challenges that we are having in ANN. Okay, so yeah, that's what all about the future advancement and applications of ANN, like enhanced learning, novel applications and ethical consideration. Not limited to that, there are multiple things available. The slide can accommodate only these things, so I have to. So yeah, that is what all about it. Yeah, sir, over to you.
Yeah, so future advancement and applications of artificial neural networks. So we have seen CNN, okay, we have seen ANN, we have seen other algorithms which are there, okay, convolutional networks, we have seen different aspects of ANN, we have seen all these technologies, they're like enhanced, the continuous research is going on, exploration is going on, and the architects they have been improved, okay, they continuously improvement is so that they can learn from complex data. Then novel applications, ANNs are being applied to emerging fields like robotics, autonomous vehicles, personalized medicine, and driving, like innovations and stuff. Okay, ethical considerations, again ANNs become more powerful. Ethical concerns such as bias, transparency, and it is very crucial, and we need to have responsible AI in application. Whenever we are developing any kind of model, we need to have ethical consideration, we need to have ethical AI policies so that we can continuously research, innovate, disrupt, but with ethical consideration of it should be a useful AI which should help humanity, help beings, all kind of beings, visible and invisible, and that should be considered while developing all these algorithms and applications. So keep learning. Let's conclude this session. Thanks a lot.
Yeah, sure, sir. So, guys, this is all about ANN. So, I will say something surprise. Okay, we're gonna see a coding part of ANN in the next session. Okay, until next session, guys. Bye, guys. I hope like you guys have understand completely the black box behind what is ANN. Okay, we're gonna see the coding part in the next session. So, until next session, guys. Bye, guys. Take care. We'll all meet in the next session. Bye, guys.